Okay, if we look around the room, we saw that everyone did this correctly on the boards, and each group made the same mistake. They stopped with 2 sig figs. So when we look at this, our original concentration, 0.348 grams per 100 mils. P1 is 1 atmosphere. C2 is our unknown, our new concentration. P2 is 2.50 atmospheres. Every one of these numbers has 3 significant figures, so we need 3 sig figs in our answer. So we multiply 0.348 grams per 100 mils times 2.50 atmospheres divided by 1.00 atmospheres is 0.870 grams per 100 mil. And all 3 groups stopped at 0.87 because that's what the calculator said. But remember, it's your job to use the calculator properly and to decide, do I need to add that trailing 0, which is significant, because remember, trailing zeros are significant when we have a decimal point written in the number. Okay, so now we're going to look at talking a little bit more about the next kind of solutions, liquid-liquid solutions. And when we have liquid-liquid solutions, it means that they are made from 2 liquids, and if they are 2 liquids, in order to be a solution, they have to be miscible. We talk about things being miscible, which means that they dissolve in each other in all proportions. So if I take and go back to that example, the whiskey and soda. If I take a little bit of whiskey with my soda, they will dissolve and mix completely. Or if I take a lot of whiskey and a little bit of soda, it will still dissolve completely. So those are miscible. They mix in all proportions. Sometimes, if they don't be miscible, we say that it is immiscible. So that's just a couple of vocabulary words. And there's not going to be a question on the test that says what does miscible mean or what does immiscible mean, but there might be a question that says these are immiscible, so what about this? What does that tell you about the polarity? So when we talk about this, we start thinking about what makes things miscible or immiscible. When we have polar solvents, and we talked about how we can tell if something is polar in the previous section. We look at the formula, we think of the Lewis structure, which leads us to the shape. We decide if there are polar bonds and if there's uneven distribution of electrons and if it's polar. And polar things then, polar solvents, will dissolve polar solutes. Nonpolar solvents will dissolve nonpolar solutes. So we talk about things that are alike dissolve in each other. So if you have a polar material, you use a polar solvent to dissolve it. This is true even when we have solid liquid solutions. When we have solid liquid solutions, the solid is our solute. It's what is being dissolved. And the liquid is our solvent, what is doing the dissolving. And we say, quick and dirty in chemistry, like dissolves like. Things that are alike will dissolve in each other. And this alike means polar versus nonpolar. Oh, I forgot to bring something with me. So I'm going to run and get some paint by number pages for you, and we're going to do a little bit of painting. And what you're going to do as soon as I grab these, you're going to take your paper and fold it into 4 sections. So you'll fold your paper like this and then open it so it's divided in 4 sections. And then you are going to paint the different sections with different solvents. We're going to use water, 2-propanol, baby oil, and hexane. You'll paint the area of your picture and then look at the intensity of the color in each section. So you can go ahead